everyone. Good morning, good evening to our webinar. So we've seen a lot of uncertainty with companies. We've seen uncertainty around trade tariffs. Now we see uncertainty around energy with the Strait of Hormuz. Before we also saw uncertainty around supply chains. And one of the things we noticed is that uncertainty tends to delay or even quell innovation. Companies are unsure what bets to make because the future is so uncertain. And of course, that's the worst thing you can do. You definitely need innovation to develop options. And so we thought it was timely to have our webinar about innovating for uncertainty, or how innovation teams can retool their approach so that with uncertainty. So my name is Arie van Berkel. I'm the Chief Product Officer here at Lux Research, and I'll be moderating today's session. Presenting today is my colleague, Anthony Schiavo, who's the Senior Director and Principal Analyst here at Lux, and specifically looking at really our forward-looking topics, AI, but also innovation management and dealing with uncertainty in this case. Before we start, a couple of hints around how. Feel free to type any questions in the question box. I'll be keeping an eye out on that box as a moderator, and I'll try to get a few questions in with Anthony at the end of this session. If we don't get to your question, or if you have a sleepless night as a result of this webinar and some questions occur to you, don't hesitate and email your questions to questions@luxresearch.inc. That's Lux Research, and we will pick up your question and respond to you through email. So if you experience any technical difficulties, I'm the one to talk to. I'm the king of technical difficulties at the moment. But the best way is to just restart your browser, refresh your browser, and see if the connection reestablishes itself. And usually that helps. So without further ado, we'll switch to Anthony, who's going to tell us how to innovate for uncertainty. Anthony, floor is yours.
Thanks, Arie, and thanks to everyone for joining me today. Yeah, we're going to be talking about this very sort of uncertain time that we're all living in. And I want to start by just asking kind of a basic question, which is why do innovation teams need to respond to risk, right? And then the focus of today's presentation is really going to be about forecasting risk and how we can apply that in a sort of an innovation context. And then I'm actually going to step back a little bit, and I want to talk to the startups, the founders, the innovators themselves in the third section. We actually have a good number of those types of folks join us on these webinars. And I think it's always interesting to kind of flip the script, and instead of talking from an innovation team's perspective or a corporate perspective, really talk from an innovator's perspective. Understand what they can do and how they can operate in this more risky environment. The point I would start by making is that risk has really become kind of a key concern. And you can see this even at a very high level in the financials of companies. I looked at chemical companies, just to take one example. And in the pandemic decade, the 2020s, the top line growth actually improved, right? From about 4% to 7% annually. And that's very interesting in the context of innovation, because most innovation teams are set up in a kind of product launch type of way. They have an innovation funnel and they're launching new products. They're essentially adding to top line growth. That's a big part of what they're doing. So top line growth has already improved, in no small part due to things like inflation. But EBITDA growth was substantially worse in this decade compared to the last decade, and EBITDA volatility increased a lot. You now have these very big swings in EBITDA as things like in the chemicals context, inputs can swing wildly in terms of cost, right? So top line growth has become more accessible, but earnings and profitability have become more challenging and more volatile. And you see this challenge really reflected in the discipline of innovation management. when you look at the publications about innovation management, you can see that risk and risk management are really occupying a much larger share. And it's especially growing in the last couple of years, but pretty consistently over the last 2 decades, this has been a growing trend. And we see this when we talk to our clients directly, both in our conversations, but also in our innovation survey. Last year we did an innovation survey that actually really focused on risk and uncertainty, and especially in a global context or de-global context, as the case may be. We're doing another innovation survey again, by the way, so please look out for that. But our innovators highlighted their main challenges as uncertainty as this key primary challenge, and also a challenge of kind of coordinating innovation across multiple groups, which was made more difficult by that uncertainty. And this is because ultimately, not all risks are truly equal, right? We have some very quantifiable risks, which I think a lot of innovation teams are relatively familiar with. Hopefully they're familiar with. Things like pure financial risks, interest rates, CapEx, material costs, sort of commodity pricing, and also technology risks, yield, specifications, CapEx. And these things can be forecasted, right? And modeled, and I think innovation teams have a pretty good handle on these. And then we have some semi-quantifiable risks, and environmental risk is a great example of this, right? Where you can totally put a price on carbon, right? And you can even forecast the cost of carbon emissions going forward. But that doesn't fully capture your risk, both because we don't have super good models for predicting what the cost of carbon will be. Maybe if you're in the EU, you have a better more structured framework for this, but certainly most of the world, that's not the case. And then there's a bunch of other potential costs or potential issues that are much harder to quantify, things like resilience or even the potential risks from pollution. Similarly, on legal and regulatory risk, there's some forecasting you do, or rather some quantifying you can do, but it's hard to quantify those. And then you have some risks that are very difficult and maybe even not quantifiable. Reputational risk, for example, societal risk, the risk of backlash. These are big stories today, and they're really very difficult to put into numbers. And so there's these three sort of big themes or big, challenges that innovators are facing. The first is bottlenecks. Of course, I'm sure everyone remembers the the Suez closure. Feels like a long time ago, but it was only a couple years. Anyway, I'm sure another major waterway won't be closed to traffic for any particular reason. Hard to imagine this happening again, right? Of course, we're living through a second version of this right now. The second is bureaucrats, right? How can we actually sort of forecast or predict how regulation is going to change? Not just on a national sort of high-level policy level, but also on a state or a local level. That's becoming increasingly important. And then last is backlash, right? How do we understand which technologies are going to generate this sort of storm of consumer rejection? And this can really translate directly into projects failing, innovations failing. So this is a really seriously major challenge, right? And the point I want to make to you, and it's sort of the thesis for this presentation, is that not quantifiable doesn't mean not forecastable. Whether it's bottlenecks, bureaucrats, or backlash, just because we can't necessarily put a firm number on this, the way we can put, an interest rate into a financial model, that doesn't mean innovation teams can't forecast these risks and then use those forecasts to build risk-aware innovation strategies. So that brings us to sort of the meat and potatoes of this. We're going to talk a little bit about how can we actually forecast these risks beyond technology, and how can we then use that to sort of inform our technology selection. There's three big categories of risks sort of relating to that framework earlier: techno-economic, regulatory, and social. We'll start with techno-economic because I think that's closest to people's current practice. How can we forecast bottlenecks? Well, one way is to really get rigorous around supply chains, right? And one good example of that, or one area where their supply chains are under a lot of pressure, is in critical minerals, right? And so you may be familiar with this, but this is our raw materials criticality framework. We measure supply risk. We look at the resilience of a raw material supply chain based on geographical spread, based on concentration, and the stability of the producers. And there's a number of sort of high-level data sources available from this. We use the World Bank Governance Index and share of global supply. And then you can also measure criticality, right? This is the amount of raw material needed to meet the projected deployment of a technology. You can look at the total stock of raw material required and then compare that to annual global production. And so give you a good sense of that criticality. So in this quadrant, we have high supply risk materials. Down here, there's lower supply risk. And then on this side of the graph, we have low criticality. And we have relatively high criticality, areas where we're going to need to really expand our production. And this type of analysis can tell us a lot about what type of technologies are really going to be necessary. So if we look at, just to take an example, solid oxide electrolyzers, you can see that most of the materials in this context are down in this lower criticality area. The demand for solid oxide electrolyzers is simply not high enough, even in the future, really, to create a huge supply crunch. Even things like copper, where there are these sort of global challenges of, hey, is there enough supply? In our industry of focus, or application of focus, it's not as big of a concern. But there are concerns about supply risk. Silicon, yttrium, lanthanum, these are materials where you have very concentrated supply chains, you have very concentrated processing, and some potential geopolitical uncertainty. So this type of analysis can then inform our technology selection, right? Our focus here should be on novel sources, right? And particularly, we can kind of abandon scalability. It's really not as big of a concern in this type of application because we're not really in that very sort of critical supply chain. We want to reduce our risk from uncertainty by creating novel sources from waste streams or unexpected places. We don't need to double or triple or 10x our supply of these materials. And so that leads us to being interested in technologies we might not care about otherwise. Of course, I think waste and industrial byproducts as a feedstock is probably a standout here, and hopefully clients are pretty familiar with it. Companies like KMX are looking at mine tailings and other waste resources as places to supply critical minerals. You can look at deep sea mining. Deep sea mining is an interesting one because it is very risky in a practical sense. There's a lot of techno-economic risk and there's a lot of political risk, but those risk profiles are different, right? You're sort of diversifying your risk compared to traditional mining. But even something like phytomining, which is the process of essentially using plants to extract minerals out of the ground, and then you take the plants, process them, typically by burning, and you're left with those mineral residues. This is something that I think for a long time has just been thought of as not scalable enough, right? To actually produce the types of minerals we need and the quantities we need. But with new technologies from companies like Singularity Hub, there's really opportunity to leverage this to create novel sources, right, that can reduce our risk. And again, we're not as concerned about that scalability. So analyzing supply chains, even in this pretty basic way, can really inform our thinking about technology selection. Well, let's move on to regulatory forecasting. How can we forecast regulation? And if you're living in America, it might seem challenging. Say what you will about Mr. Trump. One thing I think everyone can agree on is that he's tough to predict, right? He's an unpredictable guy. But I would argue that when we look at the history, there's a pretty clear trend of technology kind of creating or enabling the regulation that supports it. So if you look in the 1980s, you have DuPont developing HFC refrigerants as an alternative to the more ozone harmful CFCs. And it's really this development of these new refrigerants that enables a ban on CFCs in the next decade. When you look at the Tesla Roadster that launched in 2008 and kind of made a splash as sort of a very popular commercial electric vehicle. And then within 4 years, you have California's Advanced Clean Car Program. You have a number of other regulatory actions around this time to really start supporting the development of electric vehicle technology, through this sort of Obama era administration. And then I think in a very clear example, in the 2010s, we saw this second wave of nuclear power development. And just in the last year or so, we've seen a clear loosening of nuclear power regulations, right? And so what happens here, I think, is that these technologies, as they develop, they create a constituency, right? They create a sort of a group around them that pushes for the development of these new regulations, right? So we can forecast regulation really by forecasting technology maturity. If we understand the level of maturity of the technology, if we understand the maturity of the innovation ecosystem, how big is it? How active is it? How many people are there who care about this technology? We can begin to understand that constituency that is actually going to push for the technology regulation, and thus we can begin to do that forecasting. And at Lux, we have a tool here that allows us to understand innovation ecosystem activity, right? That's our Lux Tech Signal. It is our data-driven sort of benchmark of innovation activity, combining patents, academic publications, venture funding, early stage government funding, and some of our Lux proprietary data. And by using the Lux Tech Signal, we can begin to look at forecasting some of these regulatory timings, right? So if you look at vehicle electrification, you can actually see this is a chart here of electrified vehicle sales. You can see the big inflection point in 2020. And when we overlay this with the tech signal, as you would expect, you can see that the tech signal peaks, probably a solid 6-7 years before the sort of that inflection point of commercial adoption, right? But it's really right around that peak that we were getting those early regulations, right? As that technology increased in maturity and the innovation ecosystem began to really grow, we got to see that response in terms of regulation. And now, flashing forward, I think we're in this era where it seems like there's this anti-EV pushback, right? Certainly at the top level from the Trump administration, you have this sort of anti-EV sentiment. But what we're seeing in the tech signal is that things like fast charging, DC fast charging, all these supporting grid technologies are really now beginning to reach that point of increasing maturity. There's an increasing ecosystem of innovators. And, I think based on that, we can actually say, hey, there's likely to be supportive policy, if not at a national level, then at a state level, right? For things like load management, companies like FlexiCharge developing the technologies to allow EVs to charge in a more grid responsive way. Microgrids, right? Especially with data centers, more and more adoption of small and local microgrids and the regulations that can support those. And even vehicle-to-grid technologies, which have begun to catch on in places like the UK, I think we can expect to see more technology adoption and more supportive regulation just based on the maturity of these innovation ecosystems. And last is social, right? How do we forecast backlash? Well, I think for this, you're really going to need to go beyond the traditional innovation framework, right? And really start to understand the consumer consensus around a particular technology, right? So for something like the consensus, we use our maturity curve. This is based on our sort of measurement of consumer conversations. We've built a anthropological model that can analyze those consumer conversations, and we can understand a measure of consensus, right? If you're not familiar with consensus, this is really, understanding when people say something, how much do they agree? Good example, I'm an American, so I go to hamburgers, right? If I say McDonald's hamburger, I think most people have a very clear image of what that is in their minds. There's a very, very clear seeds on the bun, thin patty. You're probably seeing it right now. But if I say something like gourmet sustainable hamburger, that can mean a lot of different things to a lot of different people. Is it plant-based maybe? Um, is it, how is the meat raised? Is it hormone-free? There's all these different things, all these different potential meanings for those words. It's a very simple understanding of consensus, right? So when we look at something like PFAS, right, these forever chemicals, fluorinated compounds, we can see that in the maturity curve, the understanding of the concerns of PFAS in food are already quite mature. They're in this area of mainstream acceptance. About half the population is thinking in a pretty consistent way on these types of issues. In cooking and household goods, your Teflon pans, it's pretty similar. And then when you get to something like cleaning products, you can actually see a marked difference, right? There's just heading out of that early consensus into a more mainstream acceptance framework. But when you ask about health equipment and sports equipment, you actually see that right now there's still there's really a lack of consensus. People haven't really put together that understanding of PFAS as a potential concern in something like sports equipment. But we can also see that it's actually growing quite quickly. And so this can allow you to understand, okay, there's all this concern right now about PFAS in food, but really the next thing up might be sports equipment. Let's take that as an innovation challenge. You can look for things like biomaterials that can replicate the effects of some of these water repellent coatings. Surface treatments for hard surfaces like glass, again, to sort of enable that same performance without those PFAS compounds. And even things like waxes and lubricants. There's a lot of focus on PFAS-free functional materials for things like data centers, but there's actually a lot of waxes that go on skis and other sporting equipment, right? And that could be an opportunity for PFAS-free compounds as well. So the key point is, with these risks, right, whether it's bottlenecks or bureaucrats or backlash, if you can predict these risks, you can turn them into opportunities, right? You can use them to plan your innovation strategy. And what Ari mentioned, that paralysis that I think a lot of our innovation teams are facing is actually something that can be turned on its head, really turned into a benefit. Okay, so what about if you're a startup? I think there is a challenge here, and I kind of hinted at this earlier. And the reality is that innovation processes are still very growth-oriented. They're still really about launching products, right? And you see this in the innovation funnel. This is just a schematic example of it. But ultimately, if you're a startup, the corporate innovators that you will want to work with are really ultimately thinking about launching products. And so you have, I think, two choices. First, you can try and turn a risk story into a growth story. So it fits with this product launch mentality. And to give you an example of that, I think you really need to pick the right target to pitch to in order to turn risk into growth. If we compare PFAS to something like rare earths, chemical companies obviously produce PFAS compounds. That's part of their business. But a new PFAS alternative is not really a growth story for the chemicals industry. At best, it's replacing revenue that they already have. Whereas something like rare earths, well, these rare earths are not really in the chemicals industry supply chain. It's not really a risk for them. But solving this risk for other industries actually can enable them to grow, sell new products, new solvents for extraction, or new membrane markets. So here you need to pitch not to the company that has the risk, but to the company that can solve the risk and grow as a result of it. Your other strategy is to, if you want to tackle this risk more directly, you're going to have to try and develop a new business model. And a good example of this is in pyrolysis, right? We've done a lot of modeling of plastic pyrolysis. And in a general sort of baseline case, we think building a pyrolysis facility probably has a somewhat negative return. Not ideal. But obviously, things can change, right? And during this current, Strait of Hormuz crisis, uh, we've seen significant shortages and concerns about feedstock volatility and supply, especially in Asia. And we've actually seen a number of pyrolysis producers begin to sell, contracts, and I mean beyond just the sort of increased price of oil at a baseline, they've actually been able to secure supply deals with these companies that are facing these serious crunches. So if you're in this crisis scenario, your returns look a lot better, right? The challenge for startups is, just waiting for a crisis or trying to predict a crisis or be ready for a crisis is quite challenging, right? It's not much of a business model to say, oh, we're going to build this technology and then we're going to get lucky and then everything's going to work out. You need to think about how can we sell insurance, right? Can we, work with companies to essentially say, hey, ahead of this crisis, before this crisis happens, we are going to partner with you, or you're going to give us some money. You're going to help smooth out those returns, improve our returns in the non-crisis scenario. And then when the crisis strikes, which we have some confidence it will over the next maybe decade, 5 years, you'll be first in line. You're going to get preferential access, right? And that really requires those risk teams, the innovation teams, and the startups all working together. So I want to leave you with a few final thoughts as we sort of come to time and then open up for Q&A. The first is that innovation practices I do think need to change in this more risky environment, right? A lot of innovation team practices are from this era of growth and of launching products. And both from sort of an individual forecasting perspective to how we work with startups, there's an opportunity for better practices. Secondly, just because a risk is not quantifiable doesn't mean it's not forecastable, right? If you have the right data, if you have the right analysis, you can forecast some of these very sticky questions around the future of regulation or the future of consumer behavior. And lastly, these startups, they really need to start to adapt, right? The current innovation ecosystem we have, doesn't really appreciate risk reduction. I think it kind of undervalues risk reduction. So there are these valuable technologies out there, but the innovation ecosystem is going to take time to really adapt and to appropriately value risk reduction. If you're a startup today, you can't wait, right? So you need to find a way to either transmute risk into growth or, build that new business model that's going to enable that risk-solving business. So with that, I want to just say thank you, and I'll turn it back over to Ari, and I think we should have a little time for Q&A.
All right. Yeah. Thanks, Anthony. I've been monitoring our Q&A box, and I've seen some questions come in. There was quite some activity when you were talking about regulation and about technology triggering regulation, right? So this is an intriguing thought, it seems, to a lot of people. Also quite some objections, I must say. So surely
It's fair.
Not every technology development triggers regulation, right? So how do you know which ones are likely to trigger hopefully beneficial regulation, right? So if you start developing an electric vehicle, how do you know this will then subsequently create a supportive environment from the government?
Yeah, there's a couple of things you can look at. Because I think you're right. It's not every technology creates regulation, right? And you can even have relatively big technology ecosystems that fail to produce favorable regulation. I think of graphene and carbon nanotubes as a good example. There was a lot of government support for those research areas, and there was certainly a lot of research, but there wasn't necessarily government regulation. Not that there were huge regulatory barriers in those cases, but I don't want to get too far afield. I think there's a couple things you can look to. One is, what is the level of alignment with strategic priorities of the government, right? Governments have priorities. When you look at something like nuclear, clearly the grid and the maintenance of the grid has become a big challenge, right? And it's become a piece of political pressure, right? As in America and globally, the prices of electricity are rising. There's this new focus on energy security, right? So when you have a technology constituency that is aligned with a government priority, I think that's a much better candidate for regulation as opposed to, again, something like graphene, where it's like, well, sort of a pure technology or a platform technology without a really clear strategic purpose, right? And the other thing I think that's important to recognize is where is the constituency of the corporations, right? Is there alignment between the technology development and the constituency of corporations? Because they're the ones who are often doing a lot of the advocating. So if you look at plastic pyrolysis, we've seen a lot of policy advocacy. We've seen a lot of even changed policy, in the EU and globally, to make something like mass balance more of a tool, right? And then if, that's because it's not just a function of the startups, right? It's also a function of those large companies pushing for that, and this being aligned strategically with their goals, right? So, something like electric vehicles, you can look at an example of like battery swapping in the U.S., right? Who does that serve primarily? Battery manufacturers, right? And there are not a ton of battery, manufacturers in the U.S. Certainly not compared to China, right? So that's the type of technology where, yeah, we do see a increasingly mature innovation ecosystem, but it's primarily geographically based outside of the U.S. It's the major beneficiaries aren't in the U.S. from a corporate perspective, so that's something where I think we're a lot less likely to see pro battery swapping regulation in the U.S. So if you just look at that number on the tech signal, I think you need to go a little bit deeper in your analysis than that.
Right. So you have, I think, an interesting example, because we're living it right now, I think, in Europe, is autonomous driving, right? So you need to have a big enough incentive for the regulator to do something. So in this case, autonomous driving is a risk if you regulate it, because maybe those cars create accidents and then you get the blame because you allowed those cars on the road and all that. So it's not very attractive for a regulator to support autonomous driving unless there is a very big problem that is whose solution is enabled by this technology. So for example, if there were to be, and I think that's coming, a big shortage of truck drivers, which impacts supplying supermarkets and all that. So it's very noticeable for people if your supermarket doesn't get supplied. So that might trigger, right, that combination of the technology being mature enough and there being a really annoying problem, that will trigger regulation. So that's what you need to. So you need to look for annoying problems, I suppose. We have no shortage of that. I think there's enough annoying problems to
I mean, I think that's the good news, is that for, hopefully countries are becoming a bit more responsive and a bit more strategic in how they're engaging in these technologies, although not every country.
The other question that really flared up when you were talking about preparing for those opportunities. And I think that the debate that I saw happening here in the Q&A is about timing. So let's say you used all the forecasting tools that you showed, and you identified a good opportunity that, according to your forecast, right, the uncertainty and the risk around it is going to create an opportunity for you to step in and be the hero and solve it. You still have the timing issue. So maybe your analysis is correct, and there is an opportunity for your company to be the hero and solve the critical mineral crisis. But you don't know if that moment where you can really be that hero is going to appear in 2 years, or in 4 years, or in 6 years. And so the problem now is, if you're ready in 2 years, but your opportunity is only ready in 4 years, how do you maintain that capability kind of in orbit, right, stationary, for 2 years? How do you stay ready once you're ready?
Yeah, I think there's a number of ways you can think about tackling this big picture, right? One is, how are we choosing to actually develop the technology, right? Is this about internal R&D, or is this about engaging the startups, right? Because the function of the startup is essentially to offboard a lot of that risk, right? And if you want, you can just, you'll pay a little money, but a startup acquisition strategy is one where you can wait to, see that timing and that technology gap close, right, before you make the major commitment, right? I think that's maybe a little bit of an unsatisfying answer, but I think it is a strategic one for a lot of companies. If you are in that internal development mode where you're primarily focused on conducting internal R&D, I think the thing that where a lot of companies go wrong is they look at the scope of their internal operations. I see this in chemical companies a lot, and they say, okay, well, we do big scaled up infrastructure, so whatever technology we are going to develop needs to fit within the paradigm of big scaled up infrastructure. And if you can select from more modular technologies, more distributed technologies, you can build those capabilities and scaling those types of technologies. Those are technologies that are a bit more naturally flexible in terms of how you build them and the capex required, the speed to market. So if you can go for a more modular and more distributed technology strategy approach, you are going to have, I think, more success, right? And you're going to have the flexibility to meet demand when it arises. Obviously, just forecast everything successfully every time. It's not really an answer here, right? So you're going to have ways of getting that flexibility in, whether that's offloading the risk or steering your technology towards more modular approaches.
So we have time for one more question, and there's a particularly intriguing one. I see many more questions, so again, if you have more questions and you drop them in the Q&A, don't worry, we'll pick it up and we'll get back to you. If you have more questions afterwards, also don't hesitate, send them to questions@luxresearchinc.com, luxresearchinc.com. As you can see on the screen here multiple times, right? That's our URL. This one is intriguing. It's basically asking insurance or option. So the way I interpret this question, you're basically, there's two faults here that are that you kind of use both interchangeably, but they're not really interchangeably. I think the clearest one was when you were talking about PFAS versus critical minerals. So PFAS is threatening your current revenue if you're a chemical company that produces these chemicals, right? And so innovating for an alternative, you could say, is an insurance against future potential regulation or societal backlash or external costs becoming internalized and stuff like that. And so maybe you should look at it as an insurance premium. You're innovating, it costs money, but you also pay premiums to insurance companies to make sure that you are well prepared for any unfortunate events. Whereas the critical minerals one, where you were saying you need to go talk to the people who have a solution, there you're innovating, you're more like buying an option. You're buying an option into a future market opportunity that doesn't exist quite yet, but by investing in the project, you buy an option to enter that market at some point. Mm-hmm. What's your preferred way? Do you see these things more as buying options or more as paying for insurance?
I think they are more like buying options, because ultimately you are gambling a little bit on the future here, right? And they're a bit more specific and narrowly tailored, right? I think, I'm not a financial journalist or a financial expert or whatever. What I would say is individually, they're more like options. I think for an innovation team, you can think of having a portfolio of options, right? that begins to look a little bit more like general risk insurance, right? Or a little bit more like an insurance policy. But on an individual level, I think these are all pretty narrowly focused options, right? And the question is, in this options portfolio, how much are these costing me? What's my essential cost to carry these? And then what's the payout if I win, right? And I think a lot of innovation teams it's really the carry cost that sort of gets them. They think about, okay, we can make this investment, we can do this partnership, we have this bandwidth, but, there's not really a clear understanding of, hey, how can we support this over the next years? What's it going to cost for us to support this technology over the next 5 years in case the market opportunities arises? So that understanding of the options mechanism or the understanding of the innovation function as this sort of financial mechanism is not really fully mature. And I think it's something that hopefully will mature more over time.
Okay. Thanks, Anthony. And I think you hit on a potential topic for a next webinar. Let's maybe dig deeper into how to consider innovation as options.
Yeah.
For now, this concludes our webinar. We're running out of time, and Anthony and I will continue discussing, and I'm sure we'll do that all day. But unfortunately for our webinar, this is our cue. We're running out of time. So the slide presentation and the recording from this webinar will be sent to all attendees through email. You'll get it today. And after leaving the webinar, you will also be prompted for a survey. So please take some time, fill out the survey. It's really helpful to us to get feedback on the presentation and on how useful and how applicable, how practicable it is for you. So please spend some time and give us that feedback. And then, of course, check out our upcoming webinars. They're all listed on our website. They're also listed on our member site if you have a subscription. And I hope to see you soon in one of our other webinars or elsewhere. Thank you.
Thank you.